Hi there, Mrs. Thompson here, and today we're going to learn how to balance chemical equations. Okay, you need to remember the difference between coefficients and subscripts. If you're not sure, there's a little hint right there. But when you're counting atoms, what you're going to do is you're going to take the coefficient and multiply it by the subscript to figure out how many of each atom you have. So for example, if I were counting up hydrogen, I would take the coefficient of 2, multiply it by this 2, so I'd have 4 hydrogens in total. If for some reason your formula contains parentheses, in order to count the number of atoms, you have to multiply what's inside of the parentheses by what's outside of the parentheses. So I would take this 2 here and distribute it in, so 2 times 4 would give me 8 hydrogen. And then I would multiply by the coefficient. And then this 2 would also be multiplied by the nitrogen, and then multiplied by the coefficient. Okay. So we're going to try these 3. Okay, we have a 2. Well, actually, when we're doing this, we're going to take the coefficient times the subscript every time, and I'm also going to keep these in red for coefficients, blue for subscripts. Okay, so for the first one, there is a 2 in front. So coefficient of 2 times the subscript of 2, right there, gives me times 2. 4 hydrogen atoms in total. Okay, for the next one, 2 in front. Now this 2, the coefficient, applies to the entire species behind it, the whole formula behind it. So 2 times sulfur, which is a subscript of 1. It's an understood one. It's not written, it's just understood that it's a 1. That gives me 2 sulfurs in total. For oxygen, I have a coefficient of 2 still. Notice 2 went all the way down. And then times 4, because that's a subscript by oxygen. That gives me 8. Okay, next one we have magnesium and phosphate. 1 is the coefficient in front of this. Now that's also an understood one, since it's not present. So 1 times the subscript of 3 gives me 3. For phosphorus, there's a coefficient of 1 still, and then subscript of 1. Now this one is inside of parentheses, so what you have to do is you have to take the subscript that's hanging outside the parentheses and multiply it times the normal subscript that it has. So that would be like this, and that would give me a total of 2 phosphorus. Okay, for oxygen, there's a first coefficient of 1, subscript of 4 inside of the parentheses, and then a subscript of 2 outside of the parentheses, so you end up with 8. Okay, I'd like you to pause the video and do the next one and then see if you got it right. Okay, so coefficient of 5 times 1 gives me 5. For nitrogen, coefficient of 5 times what's inside the parentheses, 1, and outside of the parentheses, 2, that's 10. And then for oxygen, that is a coefficient of 5 still, 3 inside of the parentheses, 2 outside of the parentheses, so 30 oxygens. Okay, that's a skill you're going to need as we're balancing equations, so hopefully you got all of that. All right, what we're going to do is we're going to practice balancing equations. And so for balancing equations, they have to have the same number of atoms on both sides of the equation, both sides of the arrow. Okay, so right here is where it needs to be balanced. I'm just going to put myself right here in the middle. Okay, so we're just going to write down which atoms we have. This equation actually is balanced. We're just checking that balance to make sure it's correct. So coefficient of 2 and times 1 for a subscript gives me 2 lithiums. For hydrogen, it's 2 for a coefficient, subscript of 2 for 4 hydrogens. And then for oxygen, it's 2 for a coefficient, subscript of 1 for 2 oxygens. Okay, that's everything on the reactant side, on the left side of the arrow. Now all of these atoms have to be the same as what we find on the right side. So go ahead, pause the video, see if you can do those. Okay, so for lithium, 2 in front, so that's 2 lithium atoms. For hydrogen, this one's a little tricky, so let's see if you got this. It's 2 times 1, that gives me 2 hydrogens, but I also have hydrogen here, and that would be a coefficient of 1 times 2, so that would be 2 more hydrogens. And then what you would do is you would add these 2 together, so that you would say there's 4 hydrogens in total. Okay, and then we have oxygen left. So for oxygen, you had a coefficient of 2, subscript of 1 for 2 total oxygens. Okay, so this is when it's already balanced, but we need to figure out what to do when it isn't balanced, when you have to do the balancing yourself. So you're going to be placing coefficients. So here are the steps. First step, sometimes you'll be given the word equation where you have to take and find the formulas or figure out the formulas based on either their name, like dinitrogen trioxide. You can figure that one out easily. Or by using their charges, like if you had aluminum oxide, you'd have to change the name into the formula and then balance it. If that's already done for you, then you can move on to counting the atoms on each side. Then we will place coefficients that help to balance the equation. And then we'll check our numbers after we think we're completely done with balancing, just in case we change something and it needs to be fixed, or if we need to reduce the coefficients. So sometimes you'll get carried away with balancing and you'll have a ratio like 2:4. 2:4 would be reduced to 1:2. And then one special note, when you are balancing, you never ever ever change the subscripts. The only thing you can do is put coefficients on top, next in front of the equation or the formula. All right, don't want to get in front of that guy. All right, so here we go. More balancing hints. Now, these aren't steps, these are hints. If you have a polyatomic ion, I would like you to balance it as a unit, as a whole. You're welcome to balance it individually. I think it's faster if you balance them together. If for some reason you end up with an odd number of elements on one side and an even on the other, and you need to make that work, then you can double the odd number. Okay, you'll see that in the future. You'll balance free elements last. So if you have any elements that are on their own, they're not with other elements like sodium, metal, or even the diatomic elements, then you want to reserve those for last. It just works out easier that way. Okay, and then if you have atoms that are on one side twice, then you want to leave those for last. So even more last, or for the very end after you worry about the free elements. Okay, here's our first balancing example. What I'd like you to do with these is always draw a line to separate the reactants from the products. That's right underneath the arrow always. Okay. The other thing is you see these lines right here, all of these are representing a place for you to add coefficients. Okay. So then also, when you think of these, I want you to think of them in being in these packets. Okay, things like your formulas, you can't change them. You can't change what's inside the packet. So let's say I needed more hydrogen to balance this equation, and I'm going to use this one to do that. Well, if I need more hydrogen, I'm not going to just put another H to add another hydrogen, like put a subscript or anything. What I'm going to do is add a full packet of HBr. Okay. All right, so let's do that. We're going to reserve our free elements for last. That's one of the hints that we have. So zinc would be considered a free element. It's not combined with another element. And hydrogen would also be considered a free element. So that just leaves us with bromine. Okay, so we have bromine here and bromine there. And so what I can see from this is that I have one bromine on the left side of the arrow and 2 bromines on the right side of the arrow. And we want these sides to be equal. You can think of this arrow almost as an equal sign. Okay, so if we want them to be equal, that means we need 2 bromines on the left. Now remember I said you have to add a full packet of whatever the bromine comes in. So I'm going to add a full HBr to this. Okay, and now I have 2 total bromines. It also changed the number of hydrogens, and so I have 2 hydrogens, which is great because if you look at the product side, it also has 2 hydrogens. And so when I did this, I balanced the bromine and I balanced the hydrogen from the left side to the right side. Then I'll check the zinc. 1 zinc, 1 zinc. Okay? Then you'll place coefficients in front. And so the coefficients just represent how many packets of each one do you have. By leaving this blank, I'm saying that there's only 1 zinc. For this one, there's 1, 2 HBRs, so I'll put a 2 in front. This one, there's just 1, so I can leave it blank. And then in front of this one, just a 1 or leave it blank. And so if I write the ratio for this, this would be a 1 to 2 to 1 to 1. Okay, next example. Again, keeping a line underneath the arrow to separate the reactants from the products. Okay, and I'll balance the free elements last, but both of these are free elements, so I'm going to want to balance one of these. Let's just pick the aluminum. Remember we're keeping them in these distinct packets. Okay, so aluminum, I need a total of 2, so I'm going to add another aluminum. Now that's 2 aluminums. Let's look at the oxygen. There's 3 of them and 2 over here. And just like when we were balancing charge, you can think about what does 2 and 3 both go into. And so 2 and 3 both go into 6, which means I'm going to need a total of 6 oxygens on the left and 6 oxygens on the right. Let's see. I'm going to do that differently though. So if I add another oxygen, I can't just add an O. Remember it comes as O2. If I just added an O, it solved the problem, but it wouldn't be right because oxygen is diatomic. That's its formula. I can't change that. Okay, so then that's 4 oxygens. So because I have less oxygen on the left, I'm going to add more oxygen on the right, which made 6 oxygens. So let's get 6 oxygens on the left. So now there's 6 oxygens on the left and 6 oxygens on the right. And in total for aluminum, I have 2 plus 2, that's 4 aluminums. So we're going to need to balance that. Even though I've already balanced aluminum, when I change this one, that one also changed. So rechecking is a good idea always. So if I add 2 more aluminums, now I have a total of 1, 2, 3, 4. And on this side, 2 plus 2 gives me 4. Okay, so now I'm just going to add the coefficients. There's 4 aluminum, 3 oxygen, and 2 aluminum oxide. And the ratio is 4 to 3 to 2. Now, if for some reason I kept going crazy and I couldn't get it to balance until I had 8, 6, 4. 8, 6, 4, those are all divisible by 2. So we could reduce that to 4 to 3 to 2. So anytime that happens to you, it just means you kept going when you shouldn't have. So just reduce. Okay, next problem. This one looks a little longer. It is. So let's do some steps. Okay, first thing, draw a line in the middle. Okay, check to see if we have any free elements. I don't. So I'm just going to start. I can choose anywhere to start, but I'm going to start with the first one. That's aluminum. So since I have 2 aluminums on the left, but only 1 on the right, I'm going to add another thing that has aluminum in it, which is AlCl3. Okay. That gave me 2 aluminums, but now I've changed the number of chlorines from 3 to 6. So I'm going to add more chlorine to the left-hand side by adding 5 more HCl's. So with that, I have 6 in total. So let's see, that's 1, 2, 3, 4, 5, 6 chlorines. Okay, now I can see that I've changed the hydrogen but I'm going to go ahead and balance the sulfate. So what I wrote here, it says, hint, balance the polyatomic ions as a unit. Polyatomic ion. So where is the polyatomic ion? I mentioned it, it's sulfate. How do I know it's sulfate? I have those memorized still. They don't go away. All right. And one clue that I have a poly is the parentheses that you see right here. Okay, the fact that I have parentheses and a 3 outside means that I have 3 of these sulfates. I like to balance them as a whole and just say I have 3 sulfates here, so I need 3 sulfates over here. You could balance them individually and say, okay, well I have 3 sulfurs and 12 oxygens, so I need 3 sulfurs and 12 oxygens over here. Either way works. I like balancing it as a whole unit. Okay, so if we have 3 sulfates and I want 3 sulfates over here, all I have to do is add 2 more things with sulfate in it. One other thing that you can do, I almost forgot, is if you see parentheses over here and then look to the right or vice versa and the formula is exactly the same, then just put parentheses around it so you can see that you only have 1 of these. Okay, so now I've changed the number of hydrogens when I did this. Now it's 2, 4, 6. On the left, that's 1, 2, 3, 4, 5, 6 hydrogens. I just checked sulfate, so let's recheck aluminum. That's 2, that's 2. So then we can just add our coefficients. That would be 1, 6, 3, 2. Okay, I'm going to also do this again. The reason I'm doing this again is because it gets really long if you have coefficients of 6 or even 9, and later you'll have coefficients of like 17, 19, and 25. So we don't want to have to write these over and over again. So let me show you how to do that without writing them over and over again. Okay, the writing them over and over again is a really concrete way to do it so that you can add them up together pretty quickly, but it gets to be a pain once those numbers get to be huge. Alright, so I'm doing it the same way, except for this time, what I'm going to do is I'm going to write down each set that I have. So I have aluminum. Remember, I'm going to consider sulfate as a whole. There's 3 sulfates on the left and 1 sulfate on the right. So I'm going to put SO4 and not put S and O. You're welcome to do S and O, that's fine, or you could do SO4 like I do. Okay, then there's also hydrogen and chlorine. I'm going to count how many I have. I'm also going to write the same list on the right side. Now this is going to be in a different order, but I like to keep them in the same order that I wrote the left side so that I can compare them relatively quickly. Okay, so first on the left I have 2 aluminums, 3 sulfates, 1 hydrogen, 1 chlorine. On the right I have 1 aluminum, 1 sulfate, 2 hydrogens, 3 chlorines. So now I'm going to add coefficients. Okay, I'm going to add coefficients instead of writing them multiple times and then adjust what I have written. Okay, so I'll start with aluminum again. I have 2 here, 1 there. So I have to think of what could I add as a coefficient to change that from 1 to 2. Well, if I add a 2, that'll change it from 1 aluminum to 2 aluminums. So I'll cross out the 1 and write a 2 because I'm adjusting this as I go so that the numbers end up the same. The other thing that I have changed here is I have changed the number of chlorines. By adding this 2 in front, lost my mouse. By adding this 2 in front, 2 times 3 gives me 6 chlorines. So I'm going to cross out the 3 and write a 6. Okay, 6 chlorines in total. Okay, since I changed the chlorine, let's go ahead and work on the chlorine on the left side. Now, you could go in any order. This is just the order that I choose. Okay, so chlorine, I have 6 on the right, so I need to come up with a number that I would place in front of the HCl in order to get a total of 6 chlorines. So hopefully you got it. I would put a 6 there. So that would change hydrogen to 6, and it would also change chlorine to 6. Okay, so by adding this 6, you have 6 hydrogens and 6 chlorines. Okay, let's see. What should I change next? Well, if I look at my list, I have 2 and 2. Good. I have 3 and 1. Let's deal with that. So if I have 3 sulfates, that's what's outside of the parentheses here, and 1 sulfate, because remember this is in parentheses, and there's a 1 down here. Not really, but you can add that. And let's go ahead and put a 3 in front here so that we get 3 sulfates. So when I do that, I'm changing the hydrogen and the sulfate. So let's adjust that. The hydrogen is now 6. That's because that's 3 times 2. And then the sulfate is now 3 because that would be 3 times 1. So that would be 3. And then we check our numbers to make sure they're balanced. It looks like everything on our list is balanced, but you might want to check again. Go through, okay, do I have 2 alumina still? Do I have 3 sulfates? Do I have 6 hydrogens? So go through and check. And that is a 1 to 6 to 3 to 2. Okay, final and hardest problem in the bunch. So they're getting progressively harder. We're going to make some changes because this one is actually harder than the one we're going to do. So I'd like you to cross this out and write this. Okay, so this is combustion of a hydrocarbon. It's a hydrocarbon because it has hydrogen and carbon, and it's combustion because it's burning in oxygen. Okay, so we're going to do the normal steps. We're going to draw the line, and then we're going to write down which elements we have, C, H, and O, on both sides. Okay, as it's written, C, H, O, that's actually the order I would like you to balance it in. Okay. So we'll just count. There's 6 carbons, 14 hydrogens, 2 oxygens. Over here, 1 carbon, 2 hydrogens, and then for oxygen, we have that split between here and here. And so there's 1, 2, plus another, that's 3 in total. So we'll write 3. Notice I added them. Okay. Next, what we're going to do is see what's different. And I would like you to balance this in order. So balance carbon, then hydrogen, then oxygen. So 6 carbons here. We want 6 carbons over here. So we can put a 6 in front of CO2, and that takes care of it. It changes the carbon to 6. But it also changes the oxygen. Okay, so let's count that up. That's 6 times 2, that's 12, plus 1 more, don't forget this one, that is 13 in total. Okay, next, let's go with hydrogen. We have 14 here, so we need a number in front to get 14. So right now it's 2. We can put a 7 there. If we put a 7, that gives me 14 hydrogen. So we'll cross that out, write 14. It also changed the number of oxygen. Okay, don't forget that it's split, so I have to add this here plus that. So 6 times 2, that's 12 oxygens all together right here, plus the 7 that are right here, 7 times 1. So 12 plus 7 is 19. Okay, so then we have to figure out, okay, well, what are we going to put in front of that oxygen so we can get a total of 19? Well, this is the tricky part. There isn't a whole number that I can put in front of this in order to get 19. You can't use fractions, so I could say 19 halves would take care of it, but that's not going to work. We have to come up with a whole number to put in front, because you can't have half of an oxygen molecule. Okay, so let's see, what do we do? Well, the thing that you're going to do when you end up with these odd numbers, like this, like 19, is you're going to double everything. So we're going to double everything else, and so that we can fix the question mark one. So we're going to put a, oh yeah, double everything. Put a 2 in front of this one. So that's 2 times 1, 2. And then we're going to double the CO2. That's 12. We're going to double the H2O. So that's 14. And then we're going to work out how many oxygens we need to put to take care of this. But before we can do that, we need to adjust. So I've just doubled everything. Now let's count how many of each atom we have. Okay, so we have 6 carbons originally, so 2 times 6 gives me 12. And then 2 times 14 gives me 28. Okay, that's that part. Now let's go over here. Now we've got 12 times 1, so that's now 12 carbons, not 6. Okay, let's skip the oxygen, leave that for the end. Move on to the hydrogen. 14 in front of hydrogen, which is 2, a subscript of 2, would give me 28 hydrogens. Okay, and then 14, now let's add up the oxygen. So we have 12 times 2, that's 24 oxygens. Ooh, plus 14. So 24 plus 14 would give me a total of 38 oxygens. So then we have to figure out what's that question mark now? We need something that we'd multiply times 2 to get to 38. So that number is 19. 19 times 2 gives me 38. Good thing that we're not writing these over and over again, because if you had to write 19 oxygens, that would take you forever. And it would take up a lot of space. Okay, so then this ratio can't be reduced because of the 19. So this would just be, oh, I forgot to change that. Oh yeah, 19 times 2, 38. Okay, so this ratio would be a 2 to 19 to 12 to 14, and that would complete the problem. I know these notes were really long, but I hope you got the gist. If not, we'll be working on this this week.